here we can see the vestigial structure in like a whale. It would have like a femur bone, but which would be in our human thigh, but obviously whales don't walk, so it's not necessarily needed anymore. But at one point, because this is still in whales today, it's said that at one point whales were obviously like land, or the distant ancestors of whales were obviously walked on land because they still have this femur that they clearly don't use anymore today. And molecular homologies, and basically the concept of this is that all forms of life use the same genetic material, like we all originate from the same genetic material, like DNA and RNA, and the genetic codes are basically universal for all organisms. And it's an example of this can be like bacteria and humans, because obviously we're not the same and we don't like do the same things, but we all originated from a very, very distant ancestor that used the same kind of genetic makeup. And this all goes back to the tree of life, which Sophia explained yesterday, which is like if you think of a tree, the trunk of the tree would be our distant ancestor that we all came from, and then the branches of the tree would be us branching out into different species and organisms that we have today, but we all originate from the same kind of ancestor. And convergent evolutions are basically different organisms can resemble each other. So if we look at like marsupials, which would be like kangaroos, koala bears, I don't know, wombats, and other things like that, they all are a part of like, they're all mammals, but they're different from us because as humans, we give birth, a lot of mammals give birth to like actual babies, but marsupials give birth to an embryo, and then the embryo goes inside of like an embryonic pouch, and then it has to develop inside of the pouch. So we all are a part of the same, like, it's not a phylum, Doc.
Same phylum.
Okay, same phylum of the Mammalia,
Oh,
or
you mean
mammals.
the class
Yeah,
Mammalia.
it's class, okay, the class Mammalia, but we're obviously different in that kind of like feature in how we give birth and things like that. And biography can be said to have a big impact on how like things affected organisms and their evolution over time, because as we look back on what we learned yesterday, like the Galapagos finches, their the structure and the evolution of their beaks changed over time according to their environment. So when we look back into the way that the Earth was, it was all Pangea, and then when the continental drift happened, different animals spread to different environments. So of course evolutions had to occur in order for animals to be able to survive and thrive in their environment. And that's it.